Today we are going to talk about Overdrive, and an Overdrive has to do with concurrency and Swift. So before we even start talking about framework, we're gonna talk a bit about concurrency and the current state of concurrency in iOS. So let's begin. State of concurrency in iOS. Currently in iOS you have two main mechanisms to achieve concurrency in your apps, and first of them is Grand Central Dispatch. I'm sure that a lot of you guys are using Grand Central Dispatch for like multi-threading environment and dispatching and queues and everything. And you have two main classes here. You use a dispatch queue, which is like a queue that you put your work items on and you execute items on that queue. You have a dispatch work item, which is essentially just a high-level wrapper around the dispatch block, like any regular block you see in Swift. And there are also many other classes that like you can use to achieve some things like dispatch group or dispatch semaphore for locking. Yeah, so Grand Central Dispatch, really nice stuff, and especially nice with Swift 3 update. I don't know if you guys remember how Grand Central Dispatch looked with Swift 2. It was Then when you want to go bigger, you go to NS operations, and NS operation is also really good API on iOS. However, it lacks some things. But operation, you use operation to define your operation. Let's say that operation is like download an image from internet, or like synchronize database with cloud, or whatever. And when you want to execute those operations, you send them off to operation queue, and operation queue in this case will handle the execution of those tasks. And inside Foundation framework you have these two concrete subclasses of operation. One of them is block operation, which lets you create operations with regular blocks, or invocation operations. So just before we begin, they essentially let you execute work in queues, and that's a pretty powerful thing. And just show an example, we are going to start with serial queue. So the blue rectangle represents a queue and the green squares represent some work. So in serial queue, each item on the top of the queue is executed, and nothing really happens until it finishes. So it finishes one task one by one. So classic example of would be, let's say, like elevator. So if you are creating some software for elevator, you want to execute stuff not as it happens, but as you finish going between the stairs. So somebody is going from first floor to the third floor, and after that you need to go to another floor. So you execute everything serially. After serial queues, we have concurrent queues, and concurrent queues are stuff that really interests us, and they enable us to do stuff concurrently, so stuff at the same time. And yeah, let's say this. And the example like that we've all seen today is like that pizza table, and like there were 20 of us there all waiting to get pizza, but only like 3 or 4 people could get it at one time. So that would be an example of a queue. Whenever one gets a pizza, it just goes out and another comes in and gets his pizza. So yeah, pretty cool. So NS operation is a pretty cool API. It provides us with cancellation, the stuff that's very hard to implement with dispatch queues. It provides us with CrossQ dependencies, and we'll get a bit more into that later, but very powerful stuff, dependencies. And out of the box, it question, is it? Yeah. We'll come to that later, but provides better mechanism than just doing it with dispatch queues. And also out of the box, it provides us with multi-core capabilities. So if you get a newer device with more cores and more threads, it will just utilize them as much as possible and make your stuff work faster. And you have also benefit of runtime modifications. So you don't need to decide anything at the initialization time, hard word, and you can just like at one point say, hey, I want this queue to be a serial queue, and you can just do that. And this is a classic example. You would create a subclass of operation and you would define it as an instance. You create a queue, which is operation queue, and you add operation to that queue. Pretty nice. But when you go into synchronous stuff, something happens, and this is like a line from Apple documentation that says, an asynchronous operation object is responsible for scheduling its task on separate thread, and this essentially has to do with state. And if you want to do this, like it's really hard. You don't want to manage your state. You want it to be managed for you, like classical, and that's really hard. And state of NS operation looks like this. So you have several states, and they all need to be thread safe, and each operation starts with initialized state. So when you create an instance of operation subclass, it will actually start off with initialized state. And after you add that instance to a queue, say you want to execute that thing, it will move to a pending state, which says that, hey, I'm ready to execute this. After pending state, operation moves to ready state, which means that operation is ready to execute. And there might be some time between pending and ready. The classic example would be like a dependency. So if I'm waiting for another task or operation to finish before, I will be in pending state until it finishes. After ready state, the queue will go to make this operation into executing, and it will start execution. And this state can last as much as like several milliseconds to several minutes. It doesn't really matter. And once this is finished with execution, operation will be finished. And it always needs to go in this specific order. And not only this, but since each operation is cancelable, there's also a cancel state. So you can go to cancel state from either of these states, but if an operation is cancelled, then you go directly to finished mode. And like handling this in your own code is a bit of cumbersome. You know, it's not really an easy task to do, especially if you want to make it thread safe. So this is one of the problems that I had with NS operations. So say you want to use it for a synchronous task, you need to manage your state by yourself. So and you don't want to do that. Second of all, like when you do create an operation, how do you say that it provides what's its result? So if you want to execute some work, you know, what does it finish with? Is it like UI image? Is it some JSON file? Is it you can't enforce anything with just operations. So it was missing that type semantics. You just don't get here. Also, like when you finish like with default implementation in Foundation framework, you just can't say, hey, I'm finished. You actually, since you need to manage your own state, you need your own special way to say that you're finished with that operation. And that's again like thing that you just want to have already implemented. Is not something that you want to implement by yourself. And when you are finishing with something, you need to provide some result of that operation. Either it's an error or there is some actual value. So let's say you're downloading an image from the server, you can either finish with UI image, let's say, or you can finish with some API error. It doesn't really matter. But there was no way with default implementation to do that. Then, like when you do finish with something, how do you know that it is finished? Like how can you say that, hey, I'm finished and get me this result? It's really hard to do. And if there's an error, how do you know that there was an error? And all that stuff was really complicated to like implement by yourself, not very good. And also there was no way to enforce conditions on operations. So that means that, say you are synchronizing your database with cloud in some operation, and there is a condition that you're like have a connection to the internet and that you are logged in as some user. And with default implementation, you can't just implement that condition and express it anywhere. So I was working on this a bit of like a side project, and I was giving it a few hours every day, you know, guys, how it's like. And much of these things I worked it over like several months, and result of all those things was released on GitHub as an open source framework called Overdrive. And it's I think, in my opinion, it's pretty neat. It provides you with all these great features that you can use to make concurrency possible and like very, very usable. So let's go through an example. Among these things, it offers you type semantics, so you can really say that, hey, this task will return a UI image, and you get automatic state handling, so you don't need to worry about, and every method and every property is thread safe by default, so you don't need to worry about synchronization and stuff like that. You have an easy wrapping of asynchronous methods, so this comes from automatic state handling. You can easily wrap on any asynchronous method into it. You get completion blocks like on value and on error. We'll see this later. You can express conditions under which these tasks are executed, and since we have automatic state handling, we can easily implement retries. So yeah, nice things. So let's go to an example. So if you want to, let's say you want to create a network operation which will subclass an operation, you will most likely import foundation and you will subclass operation, and there is override function main which you use to define what your work actually is. And yeah, it's not very intuitive. So with Overdrive, you would have a new class named task T, which is essentially a high-level wrapper over operation, and it's a generic class which lets you define the result of this task. So in this case, we would have a network task, and we are saying that, hey, this is a task which will return a UI image, so you get all these nice Swift features there. And instead of overriding function main, you override function run. Pretty simple. So let's say that in this network task we want to fetch image asynchronously. So how do we do that? We can just wrap an asynchronous block here. So let's say we have some async call which will have a URL as a parameter, and we get returned an image and an error. And this is just like a pure example. If we want to finish and we got that image, we can just use finish with value image. So this value and error is part of, I don't know if you are guys familiar with result T, which is like a really nice thing to define the result of your operation. It's with two cases. It's either a successful result and you pass down a value with associated type, or is it a failed result where you pass the error with some error. And with this you are essentially done. When you want to create an instance of your network task, you can just create an instance, and maybe you can here in the example pass down some URL, and since we have these nice completion blocks, you can just use on value image in, and this will essentially execute after your task is finished. And since we enforce those types and we said that this is a task that returns UI image, this instance will be actual instance of UI image. It will not be some any or data or something. It will be the UI image you were looking for. And if there was an error, this block will be executed and you'll get this error here. So when you want to add and execute this task, you would create an instance of task Q, which will handle like all those execution of that work, and you would just add that task to this queue. And at this point, the task queue will schedule that task for execution and manage all its state without you even knowing it. So that's really nice. And the good thing about this is that you can enforce CrossQ dependencies. So let's say you have a really long-running task that you want to execute in background, and right after it finishes, you want to update the UI. So in the example, we'll show there will be like a background task which will fetch an image from the internet, and there will be task which is executed on UI queue which will update the UI, so you get all these nice benefits to it. And since everything is this task queue will handle like concurrency for you, you can just add like a 6, let's say, concurrent task, and they will be all executed at the same time. So that's also pretty cool. You don't need to execute them one after another. They will be all executed at the same time, and as they finish, they will call their completion blocks, and you will be notified that they are finished. So let's go to an example. So what we've got here is a simple app that will fetch a list of images from the plist and fetch them on background queue and display them in a table view. So that's a problem a lot of developers have, is how to fetch images and still like keep rendering speed and everything. So it's like really fast, but it's also doing a lot of stuff behind the scene. So I've written several like helper structures and classes that we use. We're going to use some cache, so we're going to, after we fetch the photos from the server, we're going to cache them in a, this is just a simple structure which is dictionary backed like cache, and it has several properties like set value and value for key, and has an implemented subscript which, so it behaves like a regular dictionary. There's also a dispatch queue here that we'll use to synchronize reads and writes in that dictionary. We have a photos.plist, and this is just a file with some URLs of photos that we want to display. We also have a cell UI table view cell subclass. So I haven't subclassed in a long time, so forgive me if this looks obnoxious, but we have a photo view which is just a UI image view, and we have an activity view which is UI activity indicator view that will display like a spinning indicator while the image is fetching. And in layout subviews we have just some setup code, and we have update constraints method which will actually just add constraints of and pin the UI image to the make it the exact same size as the cell. Then, so we want to utilize this framework to fetch those images, and first off, the thing that we want to do is actually fetch and read this file photos.plist, read it and convert all of these strings to actual URLs, and like have a return of array of URL objects. So we'll go here to fetch photo list task. It's a simple class which subclasses task of arrays of URL. So we already know that this will return an array of URL objects. We have defined error enum, which is have two cases, if it's invalid path or invalid data, and path is the path of this file, and invalid data is an error that might occur, let's say, if we suddenly have dictionary here and not an array, so it can't be read. And we override this run method. We create a path from bundle. We say this is a photo.plist, or if not, we finish with error. Then we create an array of those strings from that file. We use nsarrays contents of file method, and if that doesn't work, we just finish with error. And then, since we need an actual array of URL objects, we can just use flatmap to create that array. And since flatmap has a special override on optional type, we don't need to actually do anything here and unwrap it, so we'll just be good to go. And when we got that, we can just finish with value of URLs. So straightforward. Then there is a photo view controller which will actually handle the display of this table view. Do we have enough time? Yeah. So on view did load, we can actually create an instance of this task and execute this. And this is the place where we want to fetch the URLs from this file. And we can just go like, let fetch photos list equals, we create an instance of this, and we say on value, and we get passed down the URLs. And at this point, we will just assign the URLs object, which is just an empty URL array, and we'll just say table view reload data, and if there's an error, we're just going to print it. And at this point, we want to execute this. And since we got nothing else to do, I'm just going to add it to the main operation queue, and we'll be good. And now we want to create an actual task which will fetch the image from the internet. So we have a fetch photo task, really simple. There is a URL to it, and you initialize with that URL, which is the URL of image. And run method is also pretty straightforward. I'll check if there's a cached image. If yes, I'll just finish with that cached image. If there's not, I'm gonna send off a network request. I'm gonna use data contents of URL, and if I do get returned data, I will create an UI image out of it. And if I can't create an UI image out of it, I'll just throw fetch error invalid data. And after that, I'm gonna save it to the cache, and I'm just gonna finish with it. And since we do everything in do catch block, if any error occurs here, we're just gonna catch it here, and we're gonna finish with error. So let's go back to photos view controller, and at this point we want to write a method which will fetch, which will execute the fetching for a specific index path. So as cells are on the index path, we need to keep track of index paths when we are fetching something. So we create an instance of fetch photo task with that specific URL, and we can just add it on a background queue here. And the background queue is just a task queue with quality of service class. I don't know how many of you are familiar with quality of service class. It's a way to classify your work and how it executes. So we just say, hey, this is background. And since we want to execute this task in background queue, we don't want to do anything on main queue. We only want to reload the cells on the main queue. We can actually create an inline task, which will let you create a task with a block. And we, in this point, we'll just say table view reload rows at this index path that we passed. And this is the animation coming from left. And here is a pretty cool thing. Now we can say fetch task is now dependency of reload. Fetch task is now dependency of reload task. And at this point, what we do know that will happen, that is this method is going to finish first, and then after that, since it's a dependency, it will actually trigger this operation. So we know that there is a correct order enforced, and that we are executing things in correct order. And since all UI kit stuff needs to be executed on main queue, we just say task queue main add task reload task. And this is actually it. And this is just a method now that we'll call from cell for row at index path. So this is what will happen when we dequeue a cell, and we create a cell instance, and we create a URL instance, and then we just say if this image is cached, do nothing, and if it's not cached, I'm gonna start animating that spinning view on UI table view cell, and I'm just gonna call this method. So as UI table view documentation says, we shouldn't do really anything, and we should return from this method pretty fast. And the actual UI update is here. So we do everything in view display cell for row at index path. We again create a URL object, and since we know at this point that task is finished and that it's actually loaded, we know that there is an image cached. So we can just fetch the cached image from URL, and we can just set this image to a UI table view cell, and we just call set needs update constraints to update constraints between the views. And that's pretty much it. You are now done here. And if we now run this, you're going to see a bunch of random photos. Oh yeah. So it will display here. And what's cool about this is that now when we have this setup, all the network fetching operations will execute on a background queue, and all reloading stuff will execute on a main queue, which will really make this fast and nice experience. You see a bunch of random photos, don't mind them, and you can still see that it's very it's hard, so hard to scroll. And
yeah, I think that's actually our
yeah. Oh damn, sorry. Actually, it's quite fluid, you know, animation. Yeah, and it's nice. So we are caching everything, and all fetching is executed on a background queue, and we just restart everything on the main queue. And I've also added like a clear cache bar button, which will just clear the cache and show you that even if we clear cache, it will be picked up by those tasks, and everything will be just like reloaded again and displayed nicely. Did you? Not the best presentation, but I swear, like, look, like it all happens really nicely, and you still maintain responsiveness and everything while everything is executing in somewhere else. So that's kind of it. And let me just go back to my presentation for 1 second. Yeah. I also work at iZettle, if I haven't mentioned that, and if any of you like to work with Swift or like really keen to work with me, just let me know. I can hook you up. And that's essentially it. Yeah, you can reach me here on GitHub. Yeah, what a developer, GitHub. So that's it. Thank you.
Thank you, Saeed, and sorry for the mishap with the capture card. We're going to restart it during the break.
Yeah.
So do you have any questions for Saeed?
Hey, I noticed that you had a dependency across 2 queues. Is that something you've added, or was that?
That's something you get from NS operation queue. Yeah.
Didn't know that.
Hello. So it looks like a cool lib. I'll definitely check it out. But I was wondering, I think there's another project on GitHub similar to this called Procedure Kit. Have you seen it?
I'm not really familiar with that.
All right, cool. Has anyone else used it and can say anything about it?
So I can mention a few words about it. We use it in Doer. It's pretty similar. It also like just wraps around an aspiration and adds all the boilerplates that you don't want to build yourself. So I would say it's pretty equivalent.
If you have longer operations, and you want to have some state saving, if let's say the user sweeps away the app and starts it up again, how would you do that?
Well, you essentially define what saving state in your task is actually. So framework cannot actually guess what it means to save your state. So, but in that case, I would create a list of operations. So let's just decompose them into several tasks and create dependencies among them. So I know exactly which will finish and which will show an error. And in this case, just make it more diverse and create several tasks instead of doing everything in one. And with dependencies, you can just enforce the orders of execution and be done with it. Yeah.
Well, Dan, thank you, Saeed. We're gonna
thank you, guys.
Break for 10 minutes.